Manual purging refers to the process for removing non-condensable gases without the assistance of refrigeration or an automatic purger. Because non-condensable gases tend to collect on the high side of the system, manual purging is typically performed at a condenser or high-pressure receiver. Manual purging requires the deliberate opening of a refrigerant system. Since some pure refrigerant will be lost in the process, manual purging is prohibited for halocarbon systems due to environmental regulations. Manual purging of ammonia systems must only be performed by a qualified technician who has been trained in the facility-specific procedure. The following personal protective equipment, or PPE, must be used: chemical-resistant apron, chemical-resistant gloves, vented goggles with face shield at minimum. A full-face air purifying respirator is recommended. Before commencing with manual purging, proper communication must be made to inform others in the area. The technician must verify that there is a clear path of travel to a functional eye wash and safety shower or other water supply if skin exposure occurs. Anytime a refrigeration system is open to the atmosphere, it is referred to as a line break. Due to ammonia's toxicity, all line break activities are inherently dangerous. The technician must adhere to the facility's line break procedure, which undoubtedly will require a line break permit to be authorized. The basic principle for purging ammonia refrigeration systems is as follows. Connect an ammonia-rated hose to a purge valve that is located where non-condensable gases are likely to collect. Put the other end of the hose into a bucket of clean water. Slowly open the purge valve, allowing foul gas to mix with the water. A dead man valve can be used for added protection. Foul gas is a term used to describe refrigerant that is contaminated with non-condensable gases. Because of ammonia's affinity to water, it will mix with the water, forming an aqueous ammonia solution. The air, on the other hand, will bubble to the surface and escape to the atmosphere. The non-condensable gases have been removed when there are no more bubbles at the surface of the water.
So in this video, I'd like to give an overview of purging non-condensable gases manually. All right, so if an operator is asked to purge non-condensable gases, there's two different circumstances that could exist. One is the system is offline, like it's not running, and the second is the system's running. It's kind of different ways you approach it each way. So what I have depicted here is the system that's offline. Okay, so we have our compressor, but it's really not operating right now. The evaporators are turned off and everything's pretty much stagnant. So there's vapor inside this condenser, but that's it. We're really not having condensing. So that's depicted here. We have our trap of liquid. That's the orange here, but it's vapor inside the condenser. When this is the circumstance, the ideal place to purge the non-condensable gases is from the top of the condenser as depicted up here. And anytime non-condensable gases are going to be purged, it is a high risk activity because it's a line break, all right? So you want to take the utmost caution and make sure it's only done by a qualified and trained person. So I've depicted here with the angle valve in line with, let's say, a self-closing valve. That's not always done that way. Just a service valve is acceptable, but for that added safety, you could use a dead man valve. And that's how I've depicted it here. And you're going to connect that into some sort of bucket of water, all right? Because the basic principle we're going to go with is as we open the valve and it starts very, very slowly allowing foul gas to exit the pipeline here and go into the bucket of water, the ammonia will absorb with the water, okay? And so there won't be any bubbles from ammonia. Air will bubble up and exit the water. And so the operator is trained to identify when those bubbles stop, that means we have no more non-condensable gases. So that's the basic principle. So when we purge from the top, when we purge from a system that's offline, we do it from the top. And maybe I failed to say this, that's because the air is going to kind of collect the top of the condenser at the high spot. So that becomes the perfect location. Now, if we look at this system, now it's operating, okay? We got a fully operational system, either because it needs to run, they can't shut off the whole system in order to facilitate this maintenance activity. Now it's going to be a little bit different. Okay? I'm showing the exact same setup here, but now you can see we actually have condensing taking place. That's depicted by the orange kind of dots here, liquids forming and now draining in here. So this is a bit different of a circumstance. And so since the system's operating, we're no longer going to go from here where we're just going to have vapor kind of flying through that pipe from the condenser Instead, at the outlet of the condenser, on the condenser drain line, there will be a purge valve. Every condenser should have a purge valve on each circuit. If it's a multi-circuit condenser, each circuit will have its own purge valve on the drain connection. Again, for added safety, you could connect that to a dead man valve. And now we're going to connect from here. So as the compressor is operating, the non-condensable gases and the refrigerant are all mixed together, right? They're flowing through here. And now as this condensing starts to take place, what's happening is we're separating non-condensable gases from the refrigerant, which is becoming a liquid. So this connection here is rightly displayed on the top of the condenser drain. That's the only way this is going to work. If we pull off the bottom of the condenser drain, we're going to get liquid ammonia, which would be bad news. So we're going to pull off the top of the condenser drain, which is where air that's separated from refrigerant will tend to have collected. And then we're going to follow that same procedure I already described, which is to put it into a water source, a bucket of water, barrel of water, and observe that as very slowly allowing refrigerant foul gas to enter that bucket of water and wait for the bubbles to stop. Because once the bubbles have stopped, now we don't have air anymore and we're done purging non-condensables.